Hello, welcome to my next video. My name is Ramin Hossein Nejad. As I promised, in this video I'm gonna to show you a practical way to achieving and extracting all of electrical elements from a regular power signal using ATM90A36 chip. So follow the video with me. I have downloaded the two official data sheets available in the internet about this IC from Atmel Corporation. The rules of this IC is based on SPI communication, and the most achievable and available microcontroller for this aim is STM32 Discovery Board. At the first step, for easing the process, we must solder this chip into and convert it to a DIP. For soldering this IC, we use the heater and the maximum amount of temperature and air pressure. This IC is a polyphase high-performance wide dynamic range metering IC. This IC has an embedded DSP which executes calculation of active, reactive, apparent, fundamental harmonic energy over ADC signal and on-chip reference voltage. The DSP also calculates measurement parameters such as voltage, current, RMS value, as well as mean, active, reactive, and apparent. A four-way wire SPI interface is provided between metering IC and the external microcontroller. Metering IC and external microcontroller. This IC is suitable for polyphase multifunction meters which could measure active and reactive apparent energy and fundamental or harmonic energy either through four independent energy pulse output, the energy pulse output, CF1 to CF4, or through the corresponding registers. In this project, we concentrate on reading appropriate registers. You must connect the metering IC to the microcontroller according to the schematic which is drawn in page 4 of datasheets. According to this schematic and this picture. These two connections are the output of CT which should connect to the pin 3 and 4 of metering chip. Output of CT and input of current in this metering IC. The voltage pin, this pin, after alternating through the resistors will connect it to the pin 13. This pin. Finally, you should connect your STM Discovery board to your metering chip according to this picture. SDI, SDO, clock and chip select should respectively connect it to PE6, PE5, PE2 and PE4. In the next stage, the third and fourth pin of port B of Discovery board will connect to the pin 34 and 33 of metering IC. You can eliminate these four resistors pull-up. Four working states have been designed for this IC, which are controlled by PM0 and PM1. These two pins. And switching through these working states must be done according to this flow chart. For example, for switching from detection mode to the normal mode, in the first step, you should switch from detection mode to idle mode, and in the next stage you should switch from idle mode to normal mode. We must switch in this rule. As I said before, in this project, we concentrate to the reading the registers to obtain the measuring parameters such as voltage, current, and power, and etc. For reading any register, we must enable the chip by chip select by 0 and send the address of register through SPI. And the amount of register will be received through SDO. And read and write are chosen by instruction bit. For example, for reading the RMS voltage of phase A, this register, we must send 80D9. We must send 80D9 to the metering IC. This 8 is because of this instruction, reading mode. "16 bits of SPI for sending and 16 for receiving in reading section, and 32 bits of SPI is needed for writing in the metering IC. But in the STM32 discovery board, there is only 16 and 8 bits of SPI. For solving this problem, we must use the arrays. And producing 32 bits of SPI. For example, in the RMS value of voltage in phase A, we must select the chip by sending 0 to the port E pin 4, this line, enabling the chip. In the second line, in the next stage, sending the TX value and receiving RX value, sending TX value and receiving RX value. After delay, reset the chip, 15 milliseconds, and reset the chip. We read all of other registers using this method in while one loop, like as frequency, angle phase A, temperature, THD plus noise, and others. Using this method, enabling the chip, sending TX and receiving RX, delay and reset the chip. I connected my discovery board into the metering IC according to datasheet, and finally I've connected the poor resistance and one inductive motor to examine the circuit. You can see the amount of voltage, frequency, angle phase, temperature, power factor, and others. Let me examine. Thank you for watching this video.